Hey everybody, hope we're doing well. This is going to be our last section of chapter 10. Okay, we're approaching the end of radicals. We're in section 10.5, and what we're going to look at today is square root graphs. So I'm going to present my screen. There we go. And we're going to switch over to the handout. All right. Okay, so topic of the day, we're going to be looking at graphing square root functions. We've done a lot of work with breaking down radicals, solving radical equations. The last thing that we have to do in this chapter is graph them. Okay. Before we get to that, I have a warm-up problem for you. So what I want you to do, take a couple minutes, solve the problem that you see there, pause me, and then I'll walk through a solution for that before we get started on the new stuff. Okay, so take a minute, pause me, work through that, and then I'll show you the answer to that one. All right, so this is just a throwback to last week just to get you some more practice with solving the radical equations. Remember, you want to have the radical on one side isolated. So it's already all by itself. So I can square both sides. I get x squared equals x plus 30. Radical goes away. I notice this is one of the ones that's quadratic, which means I'm probably going to get two solutions. Okay, and so I'm going to have to check to see if either of those is an extraneous answer that I would throw out. So I'm going to start by just getting 0 on one side. Move my 30 over. So I get x squared minus x minus 30 equals 0. Looks like an earmuff problem. My lead coefficient is 1. So I got to figure out, there's my earmuffs. Even though it's almost summer now, we probably don't need earmuffs anymore, right? What multiplies to 1 times negative 30, and what adds up to the middle term, which is negative 1. So this is going to be negative 6 and 5. And since my lead coefficient's 1, I can use my shortcut. I don't even have to split the middle term apart. One of my factors will be x minus 6, and my other one will be x plus 5. And then I use my zero product property, and I set each of those equal to 0. So the first equation would give me 6 as an answer, and the second one would give me negative 5. Now you got to make sure that you check those answers in order to make the original statement true. So all I'm going to do is plug back in before I squared both sides, I had x equals rad x plus 30. I'm going to plug back into that. 6, let's do this in blue. So this is my check. Does 6 equal the square root of 6 plus 30? Well, that would mean 6 equals the square root of 36, and the square root of 36 is 6. 6 equals 6 is true. That means I can box that answer. That one's true. Got to check negative 5 also. Negative 5 equals the square root of negative 5 plus 30. Does negative 5 equal the square root of positive 25? Well, the square root of 25 is positive 5. That's a false statement. That means this is an extraneous solution. We cross it out. We don't use it. So the only answer to this one is x equals 6. Okay. All right, so there was just a little recap on some solving. Again, today's big goal is going to be on how do we graph the square root function, and also how can we shift it around on the coordinate plane? How can we move it left and right? How can we move it up and down? And using that, we can also identify what would the domain and range be of each of the graphs that we look at. What x values are going to be allowed, and what y values are going to be allowed. We did this when we talked about parabolas in chapter 9. We started by looking at what's called a parent function. And then think of that's just like the most basic graph that you could get for this family of functions. So, you know, for a y equals x squared, that was our parent function for the parabola. That was just our typical U shape that started at the origin. And then if you'll remember, we started moving it left and right. We started moving it up and down based on how we changed the equation. So we want to do something similar today for not x squared, but y equals the square root of x. What is the most basic parent function going to look like before we look at the children? Okay, kind of the graphs that would come about from y equals rad x if we start making changes to the equation. So the best way to start graphing a function you don't know is to make a table. I'm just going to pick some values that have nice square roots, and I'm just going to put them into the function and see what y values come out, and then I'm going to graph them. So first off, I start with negative 1. And if you plug in negative 1, here's my input. Right? It's my independent variable, and here's my output. It's my dependent variable. If I put -1 in for x, I'm going to get the square root of -1. Well, hang on a second. Can I square root a negative number? No, which means this value is undefined. It's not even going to show up on the graph. And really, that's going to be for any negative number. You can't put negative numbers in for x because you can't square root a negative number. So we would expect that this graph is going to take place completely over here, okay? Always to the left or to the right of x equals 0. So I put 0 in. Square root of 0 is 0. I put 1 in. The square root of 1 is 1. Now, when you put 2 in, square root of 2, you know, that's not a nice, clean, perfect square, so I'm going to just estimate that on my calculator. So if I do square root of 2, it's about 1.4. So I'm just going to say approximately 1.4. If I put 4 in, the square root of 4 is 2, and if I put 9 in, the square root of 9 is 3. So I'm just going to plot these as ordered pairs. Here's my x value, here's my y value. First one I'm going to plot is 0, 0. So 0, 0. Now I'm going to do 1, 1. Now I'm going to do 2, 1.4, so about there. Then I'm going to do 4, 2. And then I'm going to do 9, 3. And this could keep going. I could use 16 and I could use 25, but you get the idea. If I connect the dots, you get a graph that almost looks like half of a sideways parabola, right? If I was to take the parabola I had from right here and kind of tilt it on its side, you know, I would end up with something like this. That's the square root function. I call it the swim stroke function. If you're a swimmer, if you've ever been in the water and done like a front crawl, this would be like when your arm comes out of the water and it's about to re-enter, but you kind of just stop it there. It's the swim stroke function. That's how I think about it. All right, so this is what our parent function looks like for the square root graph. It's just going to look like, starts at the origin, and it kind of bends upward, and it grows very slowly. This is what your mind should be thinking of when you think of the parent function for the square root of x. Okay, so now the question is, what's the domain? Remember, the domain means what x values can we put into the problem. And the range is going to be all the y values that can come out of the problem. You can do this in two ways. You can do it by looking at the graph, or you can just do it by looking at the equation. If you look at the graph, you'll notice that none of the negative numbers were ever touched in this problem. This whole left side of the graph is empty. The first x value that starts is 0, and then it decides to go to the right forever. So my domain would be all the x values that are greater than or equal to 0. Now, the other way you can think about that is just by looking at the equation. We're dealing with y equals the square root of x. Since we're talking about x values that can be allowed in the problem, you ask yourself the question, what x values would be allowed under a square root sign? And the answer to that is any x value that's not negative. Whatever's under this radical, doesn't matter how complicated it is. I want to take what's under that radical and I want to set it greater than or equal to 0, because I can't take square roots of negative numbers. So really, if you don't want to look at the graph, just take what's under the square root sign and set it greater than or equal to 0. Once you solve that, you'll get your domain. And you could also use interval notation for this, so I'm going to put that on the side, bracket on 0 since it's included, and then it goes to the right forever, so infinity with a parenthesis. The range, you'll want to look at the graph. Remember, range is all the y values. You'll notice all of our y values in this problem are starting at 0 and they're going upwards forever. There's nothing at all down here. We have no negative y values. They're 0 or they're positive. So my range would be y is greater than or equal to 0. And if you did interval notation, that would again just be 0 to infinity. Okay. No negative y values in the problem, only 0 or positive. So that's just analyzing our parent function. What we want to do now is say, well, what if we want to change the equation just a little bit? What if we want to add a number on the outside or subtract a number on the inside? Okay, so we're going to start looking at shifts. What if I shift the graph around? Okay, so the first thing we're going to do is just say, what if we put a number on the outside, like a +2? Pretty much the same thing I had before, right? I had y equals the square root of x, but now I've decided to add a number to the outside of the equation. So here's what I want you to do. I just want you to make a prediction real quick for what you think that's going to do to the graph. Do you think it's going to move it up, down, left, right, flip it upside down? You know, this is kind of up to you at this point. Make a prediction for what you think is going to happen. Okay, so if you need a minute to think about that, pause me. If you've already put down your prediction, okay, what we're going to do is we're going to graph it, and we're going to see if your prediction was good to go or if maybe it did something different that you didn't expect. Okay. So here's what we're going to do. I'm going to put in some numbers into this graph, and you'll see on the graph already that I have right here, this is the original graph. This is the parent function that we graphed before. So I'm going to do the new one in blue. Okay. So I'm going to put -4 in. So if I put in -4, this is the problem we saw before. That can't happen. You can't square root a negative number. So this is still undefined. If I put 0 in, square root of 0, well, before, if you look at the front, before it came out to 0. But now, look at what we got. Now we got a +2 on the outside. So this is really going to be 0 plus 2, which is 2. Before, when I put 4 in, I got 2 out because the square root of 4 is 2. But now I got to add another 2 on. 2 plus 2 is 4. Before, when I put 9 in, square root of 9 was 3. But now I got to add 2 to it. 3 plus 2 is 5. So if I graph these as ordered pairs now, x and y, I still can't have negatives because I can't put a negative number underneath the square root. So nothing's going to happen over on this left side of the graph. But if I start at 0, it's the first number I can put in that's allowed. Instead of it being at 0, now it's going up 2 units. When I put 4 in, instead of going up to 2, now it goes up to 4. And when I put 9 in, instead of going up to 3, now it goes up to 5. So you'll notice, what did we do to all the dots we had before? All we did is we shifted them up 2 units. Okay. So my new graph is in blue. It just took all the dots I had on the graph already, and it just moved them up 2. So the graph of rad x plus 2 is shifted up 2 units from y equals rad x. So look at the domain now. What would my domain be? Well, if I look at the graph, I can still see that it's starting at 0 and moving to the right forever. So my domain is still going to be just x is greater than or equal to 0. Or you could write it as 0 to infinity in interval notation. The other way, again, of getting that is literally take what's under the radical and just set it greater than or equal to 0. The +2 does not affect the domain. What the +2 affected was the range, because it moved it up and down, which affects the y direction. If you look at your range for this, the lowest the graph ever reaches is 2, and then it goes up forever in blue. So if it starts at 2 and goes up forever, I'm looking at all of the y values that are greater than or equal to 2. They never go below that level. And if you put that in interval notation, this would be bracket, since it's equal to 2, and then it goes up forever to infinity with a parenthesis. Okay. So putting the number, adding it to the outside or subtracting it is not going to affect the domain. It's only going to affect the range. All right, so make this prediction. What do you think is going to happen if we have rad x minus 5 on the outside? What do you think that's going to do to the graph of the parent function? So put your prediction like you did for the last one. And then we're going to check this one with the calculator. So if you put your prediction down, here's what we're going to do. I'm going to put the original function and go to y equals, and I'm just going to put the parent function in y1. So square root, and then remember x is right next to the alpha button in the second column right here. Scroll down with the down arrow, and now we're going to put in, what was our new graph? Rad x minus 5. We're going to do square root of x. Now to get out of the square root, hit the right arrow just so it gets you out of the square root function. Now you're outside the rad, and we want the thick minus sign since we're subtracting. 5. You should have the parent function in y1, the new function in y2, and hit graph. Okay, so the blue one's your original. That's your y equals rad x. And then the red one, where did it move? It moved down 1, 2, 3, 4, 5 units. Okay. So addition outside moves it up, and subtraction outside the radical moves it down. How many units down did it move it? Exactly the number that you see. So this is shifted down 5 units from y equals rad x. The domain, all I'm doing is taking what's under the radical, and I'm going to set it greater than or equal to 0. So my domain would still be the same as it's been the whole time. Okay. My range, though, if I look at the graph, I'm looking at the one in red. Now it actually is allowed to have some negative values in the y direction. The lowest it ever reaches is -5, and then it decides to go up forever. So it starts at -5 and goes up to infinity. So you could write this as y is greater than or equal to -5, or you could write it as -5 to infinity in interval notation. Okay. So the range is what gets affected by that -5. Does not affect the domain if it's outside. So let's summarize that before we start messing with stuff inside the radical. So this is just a summary of what happens if you add or subtract a number to the outside. Anytime you add or subtract anything outside the radical, that's going to give you a vertical shift, meaning it moves up and down. If it's addition, this is the one we saw with the 2, that moved it up. And the subtraction is the one we just did with the 5, that moves it down. Okay. Here's what we want to do now. Now we want to start looking at what happens if we move things inside the radical. What if I add or subtract a number on the inside? Like what if I put a +3? Notice I didn't put the +3 outside, I put it under the radical, so it's probably not going to move it up and down anymore. Make your prediction for where you think that graph's going to move in relation to that parent function. Okay, what else could it do? And then we'll take a look on the graph. So if you put your prediction, let's make a table like we did before. Erase some of these dots. So here's what I'm going to do. And you'll notice I changed the values that we're using, and I did that for a reason, which you'll see once we do the graph. Okay. But we're putting in -3, 1, 6, and 13. So if I put -3 into this, the square root of -3 plus 3, well, add them up underneath first. -3 plus 3 is 0, so we're square rooting 0, which would be 0. If I put 1 in, square root of 1 plus 3 would be the square root of 4, which is 2. Square root of 6 plus 3 would be the square root of 9, which is 3. Square root of 13 plus 3 would be the square root of 16, which is 4. So you'll notice I'm adding up everything under the radical before I take the square root. You don't take the square root until the last step. Here's my original graph, y equals rad x. I'll put that in blue, and I'm going to put the transformed graph, rad x plus 3, in red. So what's kind of surprising is you maybe would have expected this to move everything to the right 3, but it actually moves it to the left 3. Here's my x value, -3, and here's my output, 0. It moved this dot to the left 3 units. If I put 1 in, now it gives me 2. So it took this dot and it moved it left 3 units. Everything's moving left 3. If I put in 6, I get 3 as an output. So what did it do? It took this dot and it moved it left 3 units. And I can't fit 13. It's too far out. But if I was to graph that, it would take the last dot and it would move it left 3 units. Okay. So your graph is going to look like this. So it took the entire graph in black and it shifted it to the left 3 units. Every single dot that you see just got moved left 3. So on the blank here, what did it do? It moved it left 3 units from y equals rad x. Now, the domain has changed this time. We're not only looking at stuff to the right of the y-axis now, we're looking at stuff to the right of -3. So we're actually allowed to use some negative numbers this time. You'll notice the first negative number I was allowed to use was -3. So my domain this time is going to be all of the x values that are greater than or equal to -3. Or in interval notation, that would be -3 to infinity, since it goes to the right forever. The range, notice, didn't change this time. All of the y values are at 0 or higher. Nothing down here, nothing down here. So there's no negative y values. So my range is unchanged from the parent function. It's just y is greater than or equal to 0. Or you could write that as 0 to infinity. So the vertical shift changes the range, but what does this horizontal shift change? That changes the domain. So if you see a number under the radical, that's going to affect the domain. It's not going to affect the range. And the other important thing to note from this example is the plus sign is actually moving it to the left, okay, which goes against what you would maybe expect. You'd probably expect it to go to the right, but that is not what happens. So make a prediction about this one. What do you think is going to happen if I throw a -4 underneath the radical? Where is it going to move it? Make your prediction, and then we're going to check it on the calculator. Okay, so moment of truth. In y equals, I'm still going to leave the parent function so we can compare. But now when I square root, I'm going to do x. You don't want to hit the right arrow this time because we actually want the -4 to be underneath. So you're just going to hit -4. And then you're going to graph it. Moment of truth. What's it going to do? What's it going to do? Okay, so where did it move it? The blue one was the original. And if you look at that low point, it moved it right 1, 2, 3, 4. So all this did is it took the blue graph and it shifted it to the right 4 units. Every single dot that you have moved right 4. So even though there's a subtraction sign, that's actually moving it to the right, to the right, to the right, to the right. Okay, a little music jam for a Monday morning. All right. Y equals rad x minus 4 is shifted right, not left, 4 units from y equals rad x. Okay, so let's look at the graph again. The domain, now everything's starting at 4 and going to the right. It's not starting at 0. So this domain we would expect to be all x values greater than or equal to 4. In an interval notation, I'll write it as well, it'll be 4 to infinity. The other way to do it, as I showed you before, is take whatever's under the radical and just set it greater than or equal to 0. I know I can't square root negative numbers. So if I take what's under that radical, not including the radical, just what's under it, I know that whatever that number is needs to be at least 0. So then I just solve that equation. I add 4 to both sides, and that tells me that my domain would be x is greater than or equal to 4. So you can do it from the graph, you can do it right from the equation. The range is still unaffected because I just moved it to the right. I didn't change the up and down motion, so it's still starting at 0 and going up forever. So my range here would be all of the y values that are greater than or equal to 0. So 0 to infinity. So let's just summarize that. Now we're looking at this plus h underneath. Adding or subtracting anything inside the radical moves things left and right. It's a horizontal shift. Remember, horizontal just means left and right motion. Okay, and the biggest part here, I'm going to put the separate box around this. It's a box within a box. Addition moves things to the left, and subtraction moves things to the right. And we did that with parabolas too. Whenever something was inside the parentheses, if you remember from the end of chapter 9, anytime I had like x plus 5 in parentheses, it moved it left 5. And if I had something like x minus 5 in parentheses, it would move it right 5. The parentheses now is just being exchanged for a square root sign, which is going to, obviously, it changes the shape of the graph a little bit, but the rules kind of should be reminding you of what we saw in section 9.5 when we did vertex form. So let's put it all together now. We're going to graph, we're going to mention what the shifts are, and we're going to state the domain and the range. So the first one I have is y equals rad x plus 6. So the first thing you should be identifying is whether or not I put the plus 6 inside or outside the radical, because that's going to affect whether or not it moves it up and down or whether it moves it left and right. And since that's outside the rad, if you look back at your box, that's going to move it up 6. So all I do is I take these dots that I see in black and I'm just going to move them all up 6. This one moves up 6, this one moves up 6, and this one moves up 6. 1, 2, 3, 4, 5. And that's pretty much it. And then you just connect the dots together. You notice I'm not putting an arrow on the other side because it's not allowed to go to the left of 0. That's because of my domain. I take what's under the radical and I set it greater than or equal to 0. So my domain here would be x greater than or equal to 0, or you could put it as 0 to infinity. The range, well, what's the lowest y value it reaches? The lowest y value it reaches is 6, and then it goes up forever. So the vertical shift is affecting that range. It's going to be all the y values greater than or equal to 6. There's your interval notation if you want to use that. Number 2, I have y equals rad x plus 5. This time I notice that the plus 5 is underneath the radical. So that's going to move things left and right. So ask yourself, okay, positive sign, based on the rule that we saw up above, is that going to move it left 5 or is that going to move it right 5? So take a pause, see what you think. And what you should say for this one is, even though my brain likes to think positive things move to the right, when it's dealing with these functions, it's moving it left 5. Okay. So all I'm going to do is take these black dots and move them to the left 5 units. This one goes left 5, this one goes left 5, and this one goes left 5. And then I connect the dots. You don't even need to make a table anymore. You can just do it straight from the graph. So here in black was rad x, and in blue now we have rad x plus 5. Okay, the black one is the parent function, and then the blue one is the transformed function. It's like the child. The domain, you can get it from the graph, you can get it from the equation. I'm going to take whatever's underneath this radical, and I'm just going to set it greater than or equal to 0, because I know whatever's in that blue box can't be negative. I can't square root a negative number. So I'm going to solve this inequality, and whatever I'm left with for x, that's going to be my domain. So what that's telling me is I can do any x value that's -5 or to the right of -5, which makes sense on the graph. If you look at your graph, here's level -5, and everything that's on the graph is to the right of that point. That makes sense. Greater than or equal to -5, or you could put -5 to infinity. And the range is unchanged. I didn't do any vertical shift. I kept it right on the x-axis, so it's anything 0 or higher, y greater than or equal to 0. So you could put that as 0 to infinity if you'd like. So let's see what happens if we start doing some that have horizontal shifts and vertical shifts. So what if I had something like y equals rad x minus 1, and then I do a -2 on the outside? What are the different shifts taking place? I'm going to start with the one under the radical. Since that's subtraction, that's going to move it to the right 1. And now I'm going to go outside the radical. Since that's subtraction by 2, that's going to move it, let's do this in blue, that's going to move it down 2. So I'm going to have to take the dots and do 2 things this time. I'm going to take this black dot, I'm going to move it right 1 unit, but then I'm going to move it down 2. I'm going to take the second black dot, I'm going to move it right 1 unit, and then I'm going to move it down 2. I'm going to take the third black dot, I'm going to move it right 1 unit, and then I'm going to move it down 2. So not only are you moving things left and right, you're also moving them up and down. It's a combination of both. You connect your dots together. Put your arrow going to the right. That's your transformed function. That's like the child. Here's the parent, rad x. And the child is y equals rad x minus 1 minus 2. So the domain, again, just take what's under the radical, and you know that this thing that I'm highlighting can't be negative. So all I'm going to do is take x minus 1 and set it greater than or equal to 0, and then solve. So my domain is anything that's greater than or equal to 1. And if you look at the graph, what's the first x value we used? 1, and then we went to the right forever. So it confirms what the inequality solved shows us. And again, you could write that as 1 to infinity if you want to use interval notation. The range, I look at the vertical shift. What did it do? It moved down 2 units. So that takes all my y values and now allows them to start at -2, and then they go up forever. So my range would be y is greater than or equal to -2. That vertical shift is what affects the range, and that horizontal shift is what affects the domain. So this would go from -2 to infinity. Last one here, we got y equals rad x plus 4 minus 5. This one I would like you to try, and then I'll put an answer on the screen for you. So pause me, try this one out. You're going to graph it, tell me what the shifts are, and then you're going to mention what the domain and what the range are. So pause me for a minute, and I'll put the answer up. Okay, so for this one, the +4 underneath, you should have gotten left 4. And the -5 on the outside moves it down 5. So all I'm going to do is take these dots, move them left 4 and down 5. So really just counting. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And then just connect your dots together. Notice the shape of the graph is staying the same every single time. Still looks like that swim stroke that I mentioned at the beginning. It's just moving to a new location on the coordinate plane. All right, so domain, you can get it from the picture, you can get it from the equation. All I'm going to do is take what's under this radical, and I know it can't be negative, so if I set it greater than or equal to 0 and I solve that, it means that x has to be greater than or equal to -4. And I'll put the interval notation so you can check that if you did that instead. And the range, well, it moved down 3 units, right? So that means that the range is now going to, oh, no, it moved down 5 units, sorry. Everything moved down 5. So the lowest this ever reaches is -5, and then it decides to go up forever in green. And, you know, it looks like it's kind of leveling off, but this will still be growing very slowly. So I want y values greater than or equal to -5, and that's what that would look like in interval notation. Okay. So that gets you some practice with the graphs. I did post a recommended practice document that has more of these. I would encourage you to do that just to get some practice seeing what the different shifts are and getting yourself used to listing the domain and range. Let's do a compare contrast question. They give you 2 graphs, or really 2 equations. They don't give you the picture. You want to compare and contrast these graphs of these radical functions. Okay, so we want to talk about, okay, where are they shifting in terms of left, right, up, and down? What's the domain of each one? What's the range of each one? Okay. So one way you can do that, if you really want to, just graph it on your calculator, graph both of them, and just compare the pictures if you want. But let's do this. Let's make a Venn diagram. So this will be for graph A. This circle will be for graph B. And then the overlap, the stuff in the middle, is going to be what they share in common. Remember, that's like the intersection. We talked about that first semester. What both sets have in common. Let's start with graph A. What's it doing? I definitely know this one is moving right 6, and I know it's moving up 3, because the 6 is underneath the radical with a subtraction sign, and the 3 is outside the radical with an addition sign. And let's look at the one on the right. I'll do this one in blue. This one, I know that's moving it left 2, and I know that's moving it up 3. Okay, so right away, what do they both share in common? They definitely both are moving up 3 units. So that's going to go in the middle. Okay, they both move up 3 from the parent function. Okay, but something that they have that's different is this one moves right 6 and this one goes left 2. So I'm going to mention that as a difference. This one moves right 6 and this one moves left 2. So that's something different that they both share. Any other similarities? Well, if they both moved up 3, that means both of them are going to start at 3 and then go up forever, right? So the range of both of these is going to be 3 to infinity. If you were to look at the graph of this one, it's going to move right 6 and up 3, so it's going to look like this. If you look at the graph of this one, it's going to move left 2 and then go up 3, so it's going to look like this. Regardless of the graph, both of these are starting at a height of 3. Okay. But the domains are going to be different. This one can only start at 6 and go to the right forever. This one can only start at -2 and go to the right forever. So this one has a domain of 6 to infinity, whereas this one has a domain of -2 to infinity. That's pretty much the main similarities and differences to keep track of. We mentioned shifts, we mentioned domain, and we mentioned range. All right, sometimes they might make you write your own. So they'll give you some information about the graph and where it got shifted, and your job is going to be to write the new function. Here's our parent function, f of x, remember that just means y, equals rad x. We want to write a radical function that is shifted up 5 units and left 7 units from the parent function. So I'm going to call the new one g of x since they already used f. And we know we're going to have to fill in some blanks. I know there's going to be a rad x, so I'm going to have to fill in something here, and I'm going to have to fill in something here. See if you can figure out for yourself first, what do you think would go on this red blank, and what do you think would go on this red blank? And then I'll fill them in. You can check them. So if it's shifting up 5, if you look back at some of the previous pages we filled out, anything that goes up or down needs to be outside the radical. So I know that 5 is going to have to go here. And since it's moving up, I know that's going to be positive. So this should be a plus 5 on the outside. The left and right motion goes under the radical. And this was the one that did the opposite of what we would expect. Left actually moved it with a positive sign. So this would be a plus 7 underneath. And that would be my function. So if you were to graph it, go left 7, up 5, it would start here, and then it would go and make that little swim stroke shape. All right, last one. I've mentioned this and given you the clue about this throughout the notes, but this is one really where you don't have the graph to look at, and it looks very complicated when you look at the equation. So if you want to know what's the domain of a function when they don't give you a graph, you have f of x equals 3 times the square root of 3x plus 5 minus 4. All you do is you remind yourself, first of all, that domain means x values. You're dealing with a square root function, which means whatever is in this box, if you put a box around whatever's underneath the square root, that box cannot be negative, because otherwise you would be square rooting a negative number. That can't happen. Whenever they don't give you a graph, take what's under the radical and just set it greater than or equal to 0, and then solve. And whatever you're left with, whenever you've gotten x by itself, the inequality that you're left with is your domain. So in this problem, the domain is not being affected by this 3, and it's not being affected by this minus 4. It's only being affected by what's under the radical, the x part. So whatever that 3x plus 5 is, whatever number that comes out to, I know it can't be negative. So I'm going to set it greater than or equal to 0 without the radical. And now I'm just going to solve for x. I'm going to subtract 5 from both sides. That's not a good greater than or equal to sign. I can do better than that. Greater than or equal to negative 5. And then divide by 3. And since you're doing inequalities, one thing I want to mention and remind you of is if you're ever going to be dividing or multiplying by a negative, you got to remember to flip that sign. So just as a reminder, if you multiply or divide by a negative, and we'll say it like we said it in class, you have to flip that sign. Good times, good times. Doesn't apply to this one, so I'm not going to flip the sign, but you might have one like that on your homework or on the practice worksheet. So there's your domain. Any number that's at least, remember at least means greater than or equal to, negative 5/3 will be okay for this function. The range is a little bit harder to do for this one without looking at the picture. So if you really wanted to know what the range was, I would suggest you go to your calculator and you graph it. So it didn't ask for it, but it's always fun to answer an extra question. So let's do that. Let's put in 3. And if you want to do times, you can. You don't have to. 3 rad 3x plus 5 all underneath. Hit the right arrow, get you out of the radical, minus 4. And my prediction here would just be, well, we said the vertical shift affects the range, so it's probably going to have something to do with that minus 4. We didn't really do a lot in this section with the numbers on the outside. All that 3 is going to do is it's going to make the graph narrower. It's going to make the swim stroke function rise into the air a little bit faster. So there's your graph. So it looks like, well, actually it does look like it's affected by that low point on the graph, right? So it looks like for this one, the lowest it ever reaches would be negative 2. Yeah, let's see, did I type it in right? 3 times rad 3x, yeah. So my range for this one never gets below about negative 2. So that's just an interesting fun fact on the side. So range. Oh, hang on a second. feel like that should go down to -4. Something must be off with my scale. I wonder if it's getting cut off. You don't have to do this on your calculator. I'm just going to test something. Yeah, it does go down to -4. I'll have to look at my calculator on the screen. That's kind of deceiving. It should be going down to this level. I don't know why the graph is getting cut off. Did I type it in wrong? 3 rad 3x plus 5. No. That is really strange. I'll look into that on my calculator. That's weird. So yeah, that's exactly what I thought. Is it's really just going to be y is greater than or equal to -4. Sorry about the confusion there at the end. Calculator's being funky. All right, so that should do it for section 10.5. Happy mathing.